Hello friends, this is Ram Murli again. I think this time you can see me. Anyway, I have promised that I would be posting some labs on YouTube and my channel. So the labs will be available only to the subscribers of my channel. So please do subscribe. However, just before posting the labs, I'm just giving a prologue of the lab sessions. What are we going to discuss? First of all, I'm going to explain to you all the necessary things today which are important and essential for data science and artificial intelligence. So let's look at them and figure out. When I'm doing the labs, you should not be seeing that. You should not be feeling that you don't know certain things and you are listening those things for the first time in your life and you don't have any clue what I'm talking about. So that's the reason I'm going to talk to you through this prologue video. What are we going to cover in our next one? Before we do anything practically, we do need to understand about data science and machine learning and artificial intelligence and a number of things, right? So let's talk about it. Sorry, this is our laboratory environment where we do our programming, and this laboratory environment is based on the data science virtual machine and Azure at this point of time. Having said that, we can do these things anywhere. So if you would like to actually do the experiments along with me, you can go to https://ds delta sierra dot xbin x-ray bravo echo alpha november .com, and of course it will ask you the username and password. Only those people who have subscribed to my channel will have access to this, and of course they will have to write an email to me expressing an interest to work on the laboratory environment. I will certainly give you access and is completely free of cost. You don't have to really worry about any cost factor here. So please do reach me, subscribe the channel, and you have to send me an evidence by email at ram@xbean.com and prove me that you are a subscriber of my channel, and I will create a user for you. So what is data science about? Data science is all about 5 different questions. How do I organize the data in groups? How do we decide on something? Is there an issue? Is there a problem? Is there somebody doing something nonsense about my data? What next? And how much should I pay for a goods? I want to buy a home. How much should I pay to buy the home? I want to buy a banana. How much I need to pay to buy a banana? I don't think you will buy one banana for your lunch at £2 per banana. But certainly you will be ready to pay 25 pence per banana. How is it possible? How are you going to say this is a good price or this is a bad price? So basically this is all data science. So there are 5 fundamental questions. The whole of data science revolves around these 5 questions. So all of machine learning revolves around 5 different questions. And these 5 questions you will be asking the machine, making the machine to learn to ask the data the combination of these 5 questions. It could be individually or a combination of these 5 questions. So let us see what are those things. Machine learning. So machine learning is a technology where you make a machine give the capability of learning things from various aspects of it. Machine learning is of 3 types. Supervised learning, where classification and regression are the different kinds of algorithms you apply. Then you do have unsupervised learning, dimensionality reduction and clustering. And the third one is the reinforcement learning. So we'll discuss about these things before getting into uh, the practical approaches. This will be a combination of 3 videos, and you have to finish these 3 videos to get into the lab environment. Without these 3 videos, you will not be able to get into the lab environment. And those people who are actually asking me to give you access of the lab environment, I will give you free of cost. Having said that, you have to satisfy me that you have watched all these 3 videos. First of all, let us discuss about the supervised learning. So let us just see the picture beside. So there are number of fruits. Okay, I don't want to teach you like a mathematics teacher teaches you. I would like to teach you with real-time examples. So I'm going to talk to you about supervised learning and classification today. So in classification and of course and supervised learning, basically, how do you differentiate them between? You have a group of a bunch of fruits there. So how do you differentiate which one is grape, which one is banana, which one is guava, which one is orange, which one is watermelon, etc. Different kinds of fruits. There are several fruits there, several kinds of fruits there. How are you going to differentiate in your real life? Forget about machine learning and all these kind of things, right? So in your real life, so as a child, you were taught that, okay, a banana will be like this. It will be yellow in color or green in color. It will be of a certain length. It will be of a certain shape, and it will taste in a certain manner. Similarly, a grape will be of a different color, a certain color. It's of a certain shape, and it's of certain size, and it's of a certain taste. And if you start eating it, the texture is of certain type, right? Likewise, every fruit will have its own properties, if I want to say. So physical properties, the properties which we look into, and of course the tasting properties and chemical properties and the smells, the flavors and the tastes and all these kind of things, right? So similarly, you need to you need to know how to identify. So basically, somebody trained you, somebody gave you some test data, and that test data is embedded in your brain. Now, as soon as you see a known fruit, you will tell me saying that this is a banana or this is an apple, this is an orange, this is a grape, this is a plum, etc. Right? So you don't need to really worry about it. So basically, somebody taught you once upon a time that how a banana looks like, how an apple looks like, how a pear looks like, grape looks like, etc., etc. And you know, and you learned. You are a machine. You learned, and you remember. Similarly, a machine learns by after being trained like you, which is called supervised learning. So next one is unsupervised learning. For example, there is a group of people there, and now a law enforcement agency or a university wants to identify who are all the people who are there in the group of people, or a law enforcement agency. For example, there are hundreds and thousands of people there in a public gathering, and they want to identify criminals. And it is impossible, virtually impossible, to train the machine to identify how a criminal looks like, right? So basically, they will have to utilize certain algorithms, and those algorithms are unsupervised algorithms. So a machine cannot be trained upfront to identify certain aspects of it. So then it is unsupervised learning. There are a number of algorithms. In tomorrow's video, we will discuss about these things. So let us think about a supervised algorithm. So let us properties. In the picture beside, you see a number of things there. There are bananas, there are brinjals, there are tomatoes, there are berries, etc. So, how are you going to differentiate veggies from fruits? How many kinds of things are there? Are we seeing something unknown? I mean, do we have a fruit which is unknown to us? Which do we have a veggie which is unknown to us? Because basically, if you travel, if you have a habit of traveling from different places in the world, if you go to certain places in the world, you will be able to identify certain fruits which you might have not seen. So you will get trained about those fruits. And once you get trained, wherever in the world, rest of the world, if you see that fruit, you will understand. Once upon a time in my childhood, I never have seen a fruit like kiwi. Now, kiwi fruit is everywhere, is available everywhere, except in India. So, similarly. So, and the most important thing is, are the real fruits, are real veggies, or are they dummies, like, dummies made of paraffin and all these kind of things. So, by looking at them, you will understand because you are trained to identify them. So you will train the machine to identify them. How do you do that? You give different kinds of data inputs to the machine, and that the data is going to make the machine understand that, okay, that is called training data set. And then you send some more data uh, to identify whether that is a fruit or a veggie, or what kind of fruit it is, or what kind of fruit or veggie is it, and all these kind of things, right? So the supervised learning, you have different kinds of things, right? So we were given, let's say, for example, we have to give the machine, we have to train the machine using training data set. A set of classes and product of trees or plants, instances of each class. We need to generate a method, right? But what do you mean by instances? Instances are nothing but features or attributes or properties and their values. Like, for example, brinjal is violet in color. It is a vegetable, and features is it's elliptical in shape, etc., etc., right? The class that instances belong to are also called labels. So basically, uh, a thing which is violet in color, about a size of banana, but it's violet in color. If you eat it raw, it will taste horrible. But if you eat it after being cooked, the taste is great, and all these kind of things. The whole thing is called brinjal, or so that name brinjal is the label. Input is a set of labeled instances. So basically, you train the data, train the machine using the data using which is called training data set. So that's the input. And of course, the testing data set, which is also the input, but using the testing data set, by comparing the training data set, the machine identifies whether these are fruits or vegetables, or what, if it is fruit, what kind of fruit it is, if it is a vegetable, what kind of vegetable it is, right? How to create a classification model. So, I'm sure you must have seen my LinkedIn article. If you have not seen, please go back to my classification article on classification on LinkedIn, which is available on my profile. So you have to read that article to understand this, right? And I will try to make it as much as. So basically, how do you identify whether it is a fruit or vegetable? So identify fruit or vegetable is the problem statement. It's the project for us. Is it a plant or tree? The product is the fruit is a product of plant or tree? Is a tree? What is the color? What is the taste? It's a plant. What is the color and what is the taste? Right? And so many other. Of course, I have given only a limited number of decision questions here, but there are a number of decision questions. This is just a small subset of the decision questions, right? So based on that, based on all these questions and answers, based on all the answers to the questions that are being asked as part of the classification, you will come to a conclusion whether it is fruit or a vegetable. If it is a vegetable, what is the vegetable name? If it is a fruit, what is the fruit's name? So that is the classification model. So basically, a method to identify, if you create a method to identify whether it is a vegetable or a fruit, is called a model. So most of the times you will see a lot of people talking about modeling. Okay, and I'm sure you must have studied in many times in newspapers saying that Royal Bank of Scotland has failed the stress testing. So stress testing is a kind of testing whether by giving certain inputs to the model, which is fed to a machine learning algorithm. That algorithm is most of the times algorithms such as Monte Carlo simulation, and the Monte Carlo simulation is the method. So it is a classification methodology. It's a combination of classification, grouping, regression, and all these kind of things. Both supervised and unsupervised methodologies put together. So, and based on that, whatever values that come out of it, will be able to say whether the bank has failed or passed the stress testing. And similarly, an organization dealing with number of customers, they need to worry about whether they want to retain the customers or not. If they are not able to retain a lot of customers, then the business is considered to be a failure. So from time to time, they will have to identify whether the customers will be able to stick to the organization or not. And there are so many number of attributes, like for example, services, satisfactory services or unsatisfactory services, quality, satisfactory quality or unsatisfactory quality will of course influence or impact the business. Unsatisfactory relationship, every customer going into the shop being shouted at by the attendants of the shop, then nobody wants to go there for the second time, right? Likewise, influencers, you and I influencing a third person, a friend of us, to go to a shop, a specific shop or a specific business or not. Competitors, if you like my training, you will go and tell the other people, hey, Ram Morla is training very good, so go and attend his training, right? If you don't like it, you will say, hey, no, his training is not very good, so don't even dare to go to him, right? So such kind of things. So that is word of mouth also. So you and I are now the influencers. So competitors. So to me, there could be a number of competitors who are training them. So basically, you will look at what kind of quality, what kind of satisfaction, what kind of capabilities of me making you understand about my training and all these kind of things will make you stick to me or not stick to me. So if you don't stick to me, you go away. If you're getting bored about my training methodology, you will be going away and you will never come back. So if you go away, I call it as a churn of a customer, right? So customer churn is a very important example of the classification. One of the algorithms that we will be using in the classification area is called naive Bayes. For example, see the picture there. A person tying some friendship band to another person. I will ask you a question. Which person looks younger to you and which person looks older to you? Obviously, by looking at the hands itself without even looking at the faces, I can tell the person who is tying the friendship band is the person who is older, and the person who is getting the friendship band tied is the person who is a younger one, right? How did you tell? So, for example, using Bayes' theorem, a person's age can be used to more accurately assess the probability that they have a wrinkled skin. So it doesn't, it is not necessary for a person to have wrinkled skin if they are older. It is not necessary. It is not a rule. It is not a law. It is not mandatory. However, the probability is very high. The chance of the person being old, having a wrinkled skin is very high, right? So, and a young person having a smooth skin, a unwrinkled skin, the probability is very high. And vice versa can happen many times, but you don't consider that. You consider that as a negative occurrence, right? So they consider it a very low chance. So when you don't consider something with a very high chance, that is not a. So as per the Bayes theorem, the probability of certain things happening is high and probability of certain things happening is low. I don't want to train you about this Bayes theorem like a mathematics teacher or a statistics teacher. You are not here to learn statistics. You are here to think about statistics. You are here to read about the statistics when you are working and quickly understand what kind of algorithms you need to apply while doing the machine learning environment, while creating the machine learning environment for that particular problem, and you have to create that and deploy those algorithms. You don't need to. However, having said that, I did not say that you don't need to know about these things. You need to know about these things, but during this training, you need not worry about all those things at this point of time. I don't want to bore you with the mathematical background of this Bayes theorem. Okay, so now Bayes theorem is like, it's all to do with probability, right? So we will discuss about the probability in a different video anyway. But to tell you, the probability is something, a study of something happens by chance. For example, you throw a dice. What is the chance of a dice showing up number one in out of the 6 faces it has? Or you throw a coin. What is the chance of the coin showing up heads or tails? In case if you throw it, if it falls back on the road, right, or the ground. So Bayes theorem is all to do with about the possibilities, probabilities, chances, and all these kind of things. So now naive Bayes is a group of algorithms. See, why did I say naive Bayes? Naive Bayes, naive. What is naive? What is the meaning of naive? What is the meaning of naive? Naive is basically innocent assumption. So I am assuming in this particular example, right? I'm assuming that a person having a wrinkled skin is an older person. The person having a smoother skin is an younger person. It is very innocent assumption. Most of the times it is correct. But having said that, it may not be correct at all. So advantages. It's relatively simple to understand and build. It's easily trained even with small data set. It's fast. It's not sensitive to irrelevant features. And the disadvantages of Bayes theorem, as I said, the person who might be tying the friendship band might be younger actually, and the person who is tying, who is getting this friendship band tied, it might be older. We never know by looking at this picture. But there is a very high chance of our postulation, right? But the disadvantage is there is no way we will know for 100% sure that one is older and the other one is younger. So different kinds of algorithms that you see during the machine learning environment. Of course, we will be doing a lab with naive Bayes algorithms, but we will be looking at different kinds of supervised algorithms, supervised machine learning algorithms. These are linear classifiers, logical regressions, support vector machines, decision trees, boosted trees, random forests, neural networks, nearest neighbors. So we will discuss about these things at a later point of time, each one of them during my classes. Okay, so thank you. As you know, my email address is ram@xbean.com. Contact number is +441908766239. You can contact me on WhatsApp. Very easy. Send me a message. So our training, the laboratory environment is available only to those people who subscribe to my channel, and you have, if you want to play on the laboratory environment on your own by getting into https://colon/xwds delta sierra dot xbean x-ray bravo echo alpha november.com. Only if you send me an evidence that you have subscribed to my videos and my channel, and you have gone through all these kind of videos. Thank you. Have a great day.